All right, welcome to today's Explainer. I want you to think about something for a second. What if our machines weren't built in a factory, but were grown? Today, we are diving into a concept that feels like it's straight out of science fiction, but it's happening in labs right now. It's called robot metabolism, and it's all about creating machines that can literally grow and heal themselves.
And I mean, really think about that for a second. Forget just running a diagnostic. What if a robot could physically patch a hole in its own body? Or what if it found a spare part just lying around and could figure out how to use it, upgrading itself right there on the spot?
You see, for decades, we've built robots like they're toasters. They have a fixed body, and if one little piece breaks, the whole thing is basically junk until a human comes along to fix it. But these metabolic robots, they're a whole different animal. We're talking about an adaptive body, something that's resilient, and maybe, just maybe, one day totally self-sufficient.
And this brings us to the official name for this whole idea. It comes from some brilliant researchers at Columbia University, and they call it robot metabolism.
So what in the world does metabolism actually mean for a robot? Let's dive into the first big idea here: machines that can literally grow. At its core, robot metabolism is all about building robots from smaller, interchangeable pieces, kind of like Legos. These modular bots can then do some pretty mind-blowing things. They can assemble themselves from a pile of parts, they can fix their own broken sections, and, this is the wild part, they can even improve themselves by scavenging for new parts from their surroundings, or even from other non-functional robots. Now, it's really important to be clear about one thing. When we say metabolism, we're not talking about anything biological. There's no food, no digestion. This is a purely mechanical and structural process. It's all about physically taking, reusing, and rebuilding with existing parts.
Okay, so how do you actually build a robot that can grow and change its own shape? Well, it all comes down to the fundamental building blocks.
The entire system is built from just one simple repeating part. It's called the truss link. The best way to think about it is like a little robotic muscle. It's a bar that can get longer or shorter, and on each end, it has a magnetic connector, so it can snap onto other links from pretty much any angle. It is, for all intents and purposes, a smart robotic Lego brick. And these links look pretty simple, right? Each one's fairly light, not too big. But here is the secret sauce. It can extend its own length by more than 50%. Now, that one simple movement, when you coordinate it across hundreds of these links, well, that's what gives these robots the power to move, to change shape, and to rebuild themselves.
And this is where the real magic happens. Just picture it, a pile of these links scattered all over the floor. First, their magnets just kind of pulled them together into these simple flat shapes. But then, by coordinating all their little extensions and contractions, they can literally fold themselves into complex 3D structures. It's like watching a piece of paper suddenly become a pyramid all on its own.
So, this all sounds pretty amazing in a lab, but does it actually work in a practical sense? Does it give a robot a real, measurable advantage? Well, the researchers decided to find out.
The team built a simple little four-sided robot out of these links, and they gave it a challenge. But they also left something else in its environment. Not just a challenge, but an opportunity, in the form of a single spare truss link just sitting there.
And what happened next was just incredible to watch. The robot moved around, it identified that spare part, it went over, picked it up, and attached it to its own body. It essentially fashioned itself a walking stick to help it move better. And the result of that one single, simple adaptation, a performance boost of more than 66.5%. That's right. The robot got over 66% faster going downhill just by giving itself a walking stick. By finding one spare part and literally changing its own body, it radically improved its ability to do its job. That is the power of what they call an open body system.
So if a simple little test like that is this effective, you have to ask, where does this technology go from here? What's the plan? Let's take a look at the proposed roadmap.
The researchers see this whole thing unfolding in stages. For the next couple of years, it's all about just perfecting the basics in the lab, self-repair, getting robots to help each other. Then, in the medium term, maybe 2 to 5 years, we could see them in some really specialized roles, like search and rescue. But the big dream, 10 years or more down the line, sending them to places humans can't easily go, deep space missions or disaster zones where they can build and repair whatever is needed all on their own.
Of course, we gotta stay realistic here. Right now, this tech is at what's called a technology readiness level of 3 to 4. All that really means is that it's a proven concept in a controlled lab setting, but it's nowhere near ready for the real world. At least not yet.
And that's because the real world is messy, right? I mean, how do you make these magnets work when they're caked in mud or dust? How do you mass-produce these links cheaply enough? How do you power a robot that's constantly changing its shape and size? And what are the rules for a machine that can decide to change its own function? These are the huge hurdles that still need to be cleared.
So, with all of those challenges, it's fair to ask, is it worth all the trouble? Why is this single idea so important? Well, because it has the potential to change the very definition of what a robot even is. This right here is the fundamental shift in thinking. For a century, we have built closed-bodied machines. A car, a phone, a traditional robot, they have a fixed design, and when they break, they're just broken. This is the dawn of open-body systems, machines that are designed not to be static, but to constantly adapt, to grow, and maybe even to evolve.
And the endgame here isn't just one cool robot. The grand vision is to create entire robotic ecosystems. Imagine swarms of machines that maintain themselves, that share parts with each other to build new structures, that heal their fallen comrades, a truly self-sustaining system that needs almost no help from us.
And that idea is just perfectly summed up by one of the lead researchers, Hod Lipson. He said, "We're going to have to teach robots to reuse parts from other robots, a machine metabolism." It's a total shift in how we think about the entire life cycle of a machine.
So that really leaves us with one massive final question. Are we just looking at a clever new way to build machines, or are we witnessing the very, very beginning of something else entirely? Maybe the birth of the world's first robotic ecosystems?